Well, here we are at the last video lesson of the year in 21st century geometry. And this, of course, is the review for Chapter 12 test. And the Chapter 12 test will be on May 22nd. And that should be the last grade in geometry for the year for you. So we're going to review the chapter in the reverse order. We're going to start with the latest material and work back towards the beginning. What we just finished up with was writing the equation of a circle when it was graphed in the coordinate plane, or writing the equation of a circle when they gave you information about it, or graphing a circle given its equation. And all of those required us to know the center and the radius. So let's begin by looking at this graph and finding the center and the radius. So the center on this one appears to be at -1 and up 2. So there's our center C. And then the radius, I prefer to find the radius by just counting horizontally to the right. So if I were to count horizontally to the right, it looks like it's 1, 2, 3, 4, 5, 6. So the radius is equal to 6. Now, the standard form for the equation of a circle, we learned in this chapter, was in this form. X minus h, that quantity squared, plus y minus k, that quantity squared, equals r squared. So notice in here, we're going to use the opposite of the center coordinates. So by that I mean for our equation, we're going to have to put x, and then the opposite of -1 would be +1 squared, plus y, and then the opposite of +2 is -2 squared. And then we have to have the radius squared. When we square 6, we get 36. So this is our equation, and this is our radius, and this is our center. And you should box all your answers when you do this chapter test. Let's take a look at another problem from this very same section. So this is a problem where they gave us information about the circle. Namely, they gave us the center. So that's good. We need that center point. Center was at -3, 4. And I'm going to go ahead and plot that. -3 and up. 1, 2, 3, 4. So there's my center. And then they just gave us another point that's on the circle. So over 3 and down 4. 1, 2, 3, 4. That puts me right here. That allows us to find the radius, and that's what we need to do next. We need to find the radius. There are two ways we can find the radius. One way is to use the Pythagorean theorem. And the way we can use the Pythagorean theorem is, we want to know what this distance is from the center out to that point P. So that's going to be our radius. But if you look here, you can see that we went down 1, 2, 3, 4, 5, 6, 7, 8. So we went down 8, and then we went across 1, 2, 3, 4, 5, 6. Across 6. So in the Pythagorean theorem, r squared would equal 8 squared plus 6 squared. Now, I just mentioned that there were two ways to do this. The other way is to use the distance formula. Now, of course, to use the distance formula, you would have to remember the distance formula. So that would be the radius is equal to the square root of the second x, which is the 3, minus the first x. So minus a -3 would give us +3 squared, plus the second y, which is -4, minus the first y, which is 4 squared. Now that will give us the square root of 100. Either way, you're going to end up with the same radius. So the radius is 10. And now we're ready to write our equation. So our equation is going to fit this form, x minus h squared plus y minus k squared equals r squared. Keep in mind we have to use the opposite of those center coordinates. So it would be x, and then the opposite of -3 is +3. And then y, and the opposite of +4 is -4 squared. And then we need the radius squared, 10 squared being 100. So there we have our equation. It also asks us to sketch the graph, Now to sketch the graph, we start at the center, and then we'll count 10 in each direction. So if I were to count 10 to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, puts me right here. And then up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then down 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usually we have only 3 points to go through, but this one, because we were given that extra P, we actually have 5. So we try to draw the best circle we can that will go through all of these points. Now it does not have to be perfect. If we wanted a perfect circle, we would use some sort of technology to draw it. So this is just a sketch of the circle. Okay, so that reviews pretty much what we did in that last section. Let's move on to the rest of the chapter. The rest of the chapter dealt with segments. Now, this was a problem where we had to find x, and this problem can be done in 2 ways. So there are 2 methods. The first method is to use the Pythagorean theorem. And the reason we can use that is we know the radius is perpendicular to the tangent, so we have a right angle. This side, from A to P, which would be x plus 9, that's the hypotenuse. So that hypotenuse squared must equal the other side squared added together. And that's what we have to work out. Let's go ahead and work that one out. X plus 9 squared means x plus 9 times x plus 9. On the other side, we have x squared plus 225. When I multiply x plus 9 times x plus 9, x times x, x squared. And then we get a 9x, another 9x, and 81. We need to get everything on one side and 0 on the other side. I'm going to move everything to the left. When I move everything to the left, I'll subtract an x squared, so that's gone. But I do have a 9x and a 9x, so that's 18x plus 81 equals 225. And you know what? We can just subtract the 81. So 18x would be equal to 144. We divide by 18, we get x equals 8. So we've now found x. But there is a second method. And the second method is why it shows up in this particular chapter. The Pythagorean theorem, we could have used at pretty much any time. But in this chapter, we have a tangent down here from A to B. And if I was to extend this through P all the way out to the circle, that's going to be an additional x, and this whole thing will be a secant segment. So I need that whole length. Well, that's going to be 2x plus 9. And then we can use a secant and a tangent. For a secant, recall that we take the outside times the whole length. And for a tangent, well, we only have an outside. So we take outside times outside. The outside of the secant is a 9. The whole length we just wrote down was 2x plus 9. And the outside is 15 for the tangent. So that gives me 18x plus 81 equals 225. And you'll notice that that matches exactly with what we had there. So we would get the same answer, x equals 8. Either method will work. In this problem. Okay? Let's move on to another one of these secant and tangent problems. Now this one, there's only one method for it. We do have a secant. This top one is a secant. And the bottom one is a tangent. So we're going to use the secant and tangent method. We just reviewed that as our method 2 above. So secant, we take outside times whole. And tangent, we only have outside. So we take outside times outside. When I taught this to you, I strongly encourage you to label this whole length. That whole length would be x plus 8. So for the secant, we're going to be taking 8 times x plus 8. For the tangent, of course, we have only the outside, so it's 10 times 10. Take a look at that setup for a moment and see if that makes sense to you. Okay, let's go ahead and work this one out. So when I distribute the 8, I have 8x plus 64. 10 times 10, of course, is 100. We'll subtract the 64. We get 8x equals 36. We divide by 8, we get x equals 4.5. And x was all they asked us to find. And again, in this chapter on the test, you must box your answers. Otherwise, your teacher won't know what is your answer. And sometimes we have to eliminate some of the choices for our answer. Okay, let's keep going on the review. This one is just a little bit different. In this particular problem, we actually have a secant and another secant. So for both of them, we're going to use outside times whole. Now for the whole length on this top one, that whole length is going to be the x plus the 5. So on that top one, the outside is 5. I guess I didn't need that parenthesis around that. And the whole length was x plus 5. For the bottom one, the one I'm highlighting here in blue, the outside is clearly 7, and the whole length would be 4 plus 7, which is 11. Take a look at that setup and see if that setup makes sense. Okay, if it does, time to just carry through with the algebra. Distributing the 5, we get 5x plus 25. 7 times 11, 77. We'll subtract the 25. We get 5x equals 52. We divide by 5. We get x equals 10.4. Now, the directions here told us that we were supposed to round to the nearest hundredth, but this time we didn't even have to worry about that because the decimals were less than the hundredth spot. Okay, let's try another one. Number 6 is also secant segments. They're both secant segments. So both of them will follow the pattern of outside times whole equals outside times whole. Now again, this is not a formula. This is simply a concept, a pattern that you have to know. And I have encouraged you on each of them to go ahead and label the whole length. So that whole length would be x plus 2 plus 10, or just x plus 12. The whole length on this top one is 11 plus 9, so that whole length is 20. That means on the bottom one, the outside being 10, the whole length being x plus 12, that would be what I get on the bottom. On the top one, the outside is 9, and the whole length is 20. Again, please look at that one and see if that makes sense to you. Okay, let's go ahead and work this one out. Distributing the 10, we have 10x plus 120. 9 times 20 comes out to be 180. Finishing this, we'll subtract 120, gives us 10x equals 60. So x equals 6. Now, don't box that yet, because if you look up here, they asked us to find the length of AB. So this is not your answer yet. We need to find A to B. To find A to B is really x plus 2, so A to B is now going to be 6 plus 2. A to B comes out to be 8, and this is our answer. So read the problem carefully. Here we had to substitute back in. And always box your answer. And only box your answer. Okay, let's take a look at another type of segment we studied. Now, these were back towards the beginning of the chapter, and these were called chord segments. Chord segments had a whole different pattern. On a chord segment, we took first part times second part equals, on the other chord segment, first part times second part. So, for example, if we take this first chord segment right here, first part times second part would give us 5 times x, which is 5x. On the other chord segment, which would be this one right here, if we take first part times second part, we'll end up with 3 times 8. Now, finishing up the algebra, we have 5x equals 24. Dividing by 5, we get x equals 4.8. And this time they only asked us to find the x. Don't forget to box your answer. Let's take a look at another one of these chord segments. So here we have, once again, chord segments. So once again, we're going to use first part times second part equals first part times second part. Now, it doesn't matter which one you start out with. Let's start out with this one right here, the yellow one, the one I just highlighted. First part times second part, 3 times x plus 2. Let's take a look at the other chord segment. First part times second part, 4 times 9. Take a look at that setup. Most students that get the setup correct get the problem correct. Let's finish the algebra. Distributing, we get 3x plus 6 equals 36. Subtracting 6, 3x equals 30. Divide by 3, we find out x is 10, and x was what they asked us to find, so we box that. Any questions on that chord segment problem? If you do, please go ahead and see me in the Teams app. Let's take a look then at another type of segment. So in this one, we have a radius perpendicular to a chord. That's what that box will mean, perpendicular. Well, when that happens, it bisects the chord, and it also bisects the arc. Now, the reason that's so helpful is this. They've asked us to find the radius. I'm going to go ahead and draw the radius in from P to B. So that's what we're looking for. We can find that radius using the Pythagorean theorem. But in order to do that, we would have to know this piece from P to C. Hey, you know what? They gave us that one. P to C is 8. So this one is 8. But we'd also have to know C to B. And C to B we can find. The reason we can find C to B is if it bisects the chord, and I know A to B is equal to 30, then that means that C to B would be half of 30, which is 15. So this is 15. And now we can go ahead and use the Pythagorean theorem. The radius squared will equal 8 squared plus 15 squared. And when we work that out, 8 squared plus 15 squared works out to be 289. R squared is equal to 289. To finish solving that, we have to take the square root of both sides. When you take the square root of both sides, you actually get two answers. You get 17 and negative 17. Okay, but we can't have a negative radius. And that's why it's so important we box our answers, because our only answer is really r equals 17. Don't forget to box your answers. Okay, let's take a look at another type of segment problem in this chapter. Now, in this one, you'll notice that we have congruent arcs. You can see that this yellow arc is marked congruent to this green arc. That's what those little tick marks mean. And what we learned in this chapter is congruent arcs have congruent chords. So that means that m to n is going to equal j to k. Now, they've given us m to n, 3x plus 8. And they've given us j to k, 5x minus 4. Now it's set up. The rest is just algebra. We'll subtract a 3x on both sides. We end up with 2x minus 4. We'll add 4 on both sides. 12 equals 2x. Divide by 2, x is 6. And that's all they asked us to find was the x. So we box our answer. Congruent arcs have congruent chords. Likewise, congruent chords would have congruent arcs. Let's take a look at another type of segment in this chapter. In this chapter, we have two tangents to the same circle. Now, the concept that we have to use here is two tangents to the same circle from the same point are congruent. So that means that this A to B will be congruent to B to C. Those two are going to be equal to each other. AB is going to equal CB. So 2x squared plus 3 will equal 53. And the rest is just algebra. Subtracting the 3, dividing by 2, and then taking the square root. Now when you take the square root, remember you do get two answers, x equals 5 and x equals negative 5. This time, both will work. And that's because if we were to check this negative 5, 2 times negative 5 squared plus 3 is 2 times 25 plus 3. That's 50 plus 3. That's 53. Checks out. So both work. Both work. So you must box both answers. Don't forget that. Sometimes the negative works perfectly fine. Okay, let's move back further, closer to the beginning of the chapter. Now, this chapter began with a study of arc length and circumference and area of a sector and area of a circle. In this particular problem, they ask us to find the circumference, and they give us information about part of the circle. This is information about part, and that's information about part. So they've told us this arc length, they've told us the angle, and they want us to find the circumference of the whole circle. This is a situation where we will use proportions. And we will use proportions to compare the part of the circle to the whole circle. For example, the degrees in the part of the circle are 35 degrees. The degrees in a whole circle are 360 degrees. The arc length in the part of the circle, 21 inches. And we're looking for the circumference of the circle. We always solve proportions in the same way. We always solve them by cross multiplying. 35 times c is 35c. 360 times 21, 7,560. We divide by 35. The circumference comes out to be 216, and the label would be inches. Anytime they give you information about parts of the circle, but then they ask for something in the whole circle, you're going to use these proportions. Let's try another problem. So in this problem, they ask us for the area of the whole circle. And once again, they give us information about the part of the circle. So yet again, we're going to use proportions. And once again, we're going to compare the part to the whole. The degrees in the part, you can see, are 126 degrees. The degrees in a full circle, we just reviewed, 360 degrees. The area of the part was 38 square centimeters. And we're looking for the area in the whole. And of course, to solve it, we have to use cross multiplying. 126 times a, 126a. 360 times 38, 13,680. We divide by 126, and we get an area of 108.57 to the nearest hundredth. And the units on area, centimeters squared for this problem. Recall that the units on area are always squared. So anytime you're given information about parts of the circle and asked for something in the whole circle, that's when you use these proportions. Now let's take a look at where we're just trying to find something about the part. So in problem 14 here, we're asked to find the area of the sector. So that's this blue part. We're looking for the blue area. To find that area of the sector, we first need the fraction of the circle. The fraction of the circle is going to be the number of degrees for the part divided by 360. That's the fraction of the circle. And then we multiply it times pi, and then times the radius squared. And that's because area of a circle is pi r squared. So the fraction of the circle times pi r squared. They ask us to round to the nearest hundredth, so we put this whole thing into our calculator, including the pi symbol. And the area here works out to be 137.44 centimeters squared. Remember, the units on area are always squared. Pretty straightforward. Now you will have to know that formula because it will not be given to you on the test. Let's take a look at another problem. This time let's take a look at an arc length problem. So here they ask us to find the length of the arc. They're really asking us for this length out here that I've highlighted in green. Now, arc length is typically shown with a capital L. And again, we need the fraction of the circle. So that's the degrees, 20 degrees, divided by 360. That's the fraction of the circle. This time we take it times 2 pi times the radius. So fraction of the circle, degrees divided by 360, times 2 pi r. Yet again, they've asked us to round to the nearest hundredth. So when we put this whole thing into our calculator and we round to 2 decimal places, we come up with 3.14 inches. Notice the units on arc length are just linear units. They are not squared. Let's try another problem. This one's a little different. In this one, they've asked us to determine the radius, and they gave us the area of the circle. So we actually begin with the formula for the area of a circle. And again, you have to know this. This will not be given to you. They've told us what to put in for the A, 56 pi. I'm not going to write the units in this time. And that equals pi r squared. The rest is just algebra. So to solve this one, we'll divide by pi on both sides. pi's, of course, just cancel. We have 56 equals r squared. To finish this, we have to take the square root of both sides. Now, you will get two answers when you take a square root. You get a positive answer, 7.48, and you get a negative answer, negative 7.48. But as we've already mentioned once in this review, you can't have a negative radius. So our answer is going to be the positive 7.48. And don't forget the units. It's in feet. So you must box your answer. One last problem on the review, and then you'll be all done with the video. Now, this last one, once again, has one of those secant segments and a tangent segment. When we've done these problems, I've always asked you to write down this whole length. So that whole length on the secant segment, x plus 1500. And we remember for the secant segment, we take the outside times the whole length. And for the tangent segment, we take, well, there is only an outside, so we take outside times outside. So for that top secant segment, this one that I've highlighted in blue, the outside is x, and the whole length we just labeled as x plus 1500. For the tangent segment, the one that I just highlighted here in green, well, there's only an outside, so it's 1800 times 1800. The rest of it is really just algebra. We distribute the x on the left, x squared plus 1500x. 1800 times 1800. That's 324, and then 4 zeros. We have to get 0 on one side, so we can solve the quadratic equation here. X squared plus 1500 minus 324 and 4 zeros equals 0. Now, when we solve this, we're going to want to use the quadratic formula. So, putting this into our quadratic formula, we would have x equals negative 1500, oops, one too many zeros, let me erase one of those, negative 1500 plus or minus the square root. Now we have to take the b squared, so 1500 squared minus 4 times the a times the c, which is the negative 324, and then 4 zeros. And that entire thing, including the negative b, divided by 2 times the a. Now, as you've seen me do many, many times, I like to work out what's underneath that square root sign. So this time, I have negative 1500 plus or minus, and beneath the square root sign, I have a 1521 and then 4 zeros. And the bottom, of course, 2 times 1 is just 2. As we've seen many times, this now is split into two possibilities. One uses the negative. Don't forget to put a parenthesis around the entire top. And the other uses the positive. And by positive, I mean the positive in front of the square root sign. Now, on the top one, when I put that into the calculator and I round it to the nearest whole foot, I ended up with negative 2700. On the bottom one, I ended up with 1200. Once again, x was a distance along a trail. You can't have a negative distance, so we can't use this one. So our answer is just going to be the bottom one, But we do have to label it, and it's labeled in feet. So this would be our answer. And again, you must box your answers on the test. Okay, that reviewed everything in this chapter. If you need to look at these a few times, please do. And remember, I'm available in those help sessions from 2 to 4 each school day, except the day of the test. I can't help you on the day of the test because